Hello viewers and welcome to my YouTube channel. In today's video we will be completing the pending eigenvalue and eigenvectors question from IIT JAM 2019 question paper. So let's get started. So this is question number 27 from section A carrying 2 marks. The set of eigenvalues of which one of the following matrices is not equal to the set of eigenvalues of the given matrix. So we are going to call this matrix as M, and we wish to find out the matrix from the given 4 options whose eigenvalues are different from that of M. So first of all, if suppose say lambda 1 and lambda 2 are eigenvalues of this particular matrix M, then we know that lambda 1 plus lambda 2 is equal to the trace of M, and that is equal to 1 plus 3, 4 in this case, while the product of the eigenvalues lambda 1 times lambda 2 must be equal to the determinant of M, which is 3 minus 8, that's negative 5. Now since we are looking out for matrix whose eigenvalues differ from that of M, we should have that the sum should either be not equal to 4 or the product of the eigenvalues should not be equal to negative 5. In other words, we are looking out for the matrix whose trace is either not equal to M or the determinant is not equal to negative 5. So that is going to be our whole objective while solving this problem. Now suppose say I call the matrix in option A as A, then we have that trace of A is equal to 4. That means that if it has two eigenvalues lambda 1 and lambda 2, then lambda 1 plus lambda 2 is equal to 4, and while the product lambda 1 times lambda 2 will be equal to its determinant, that's 3 minus 8, which is negative 5. That aligns with the given matrix M. For the matrix in B, the sum of the eigenvalues is again 4, while the product of the eigenvalues is equal to negative 5. So that's also fine with M. For matrix in option C, the sum of the eigenvalues is 4, while the product is again equal to 3 minus 8, that's negative 5. And lastly, in option D, the sum of the eigenvalues we get is 8, and that doesn't matches the trace of M. Also, if you look out for the product, so that is lambda 1 times lambda 2, so that's going to be 8 minus 3, which is 5, which is again not in alignment with the product of eigenvalues of the given matrix M. Thus, option D has set of eigenvalues which are different from the given matrix M, and option D is going to be the correct answer. Now moving on to the next question. This is question number 56, numerical answer type carrying 2 marks, and we are given a vector. So if vector 2yz, where y and z are real numbers, is an eigenvector corresponding to the real eigenvalue of the given matrix, we have a 3 by 3 matrix here, then we wish to find out the value of z minus y, and you can see that z and y are present in this particular eigenvector. So for this, what we are going to do is we are going to first find out the real eigenvalue of the given matrix. So call the matrix as M. Then we know that the eigenvalue is given by solving the characteristic equation, and that is given by M minus lambda I, its determinant equals 0. So this gives us that determinant of negative lambda 0, 2, 1, negative lambda, negative 4, 0, 1 and 3 minus lambda must be equal to 0. Let's first evaluate the determinant now. So the determinant of the matrix is, we will start with this entry. So we have got negative lambda times the corresponding minor. So the determinant of this minor matrix is negative lambda times 3 minus lambda and plus 4. Then we have got the next entry as 0. So we'll have a minus 0 here, and followed by 2. So we are going to have plus 2 times, and the minor with respect to 2 is this matrix. So the determinant is 1 minus 0, that's 1, and this should be equal to 0. Simplifying the expression on the left, we get negative lambda times negative 3 lambda plus lambda square plus 4 plus 2 is equal to 0, which gives us we'll multiply the bracket by negative lambda and we get 3 lambda square minus lambda cube minus 4 lambda plus 2 is equal to 0. Now you can see that the leading term is negative lambda cube and it has a negative sign. So we'll be multiplying the entire equation by minus sign or by minus 1, and also rewrite the equation in a descending order of power. So we get that lambda cube minus 3 lambda square plus 4 lambda minus 2 is equal to 0. Now if you will observe that the coefficient for lambda cube is 1 and the other odd power of lambda over here has coefficient as 4. So we have got the sum to be 1 plus 4, that's 5. And then if you look at the even powers, then we have got negative 3 as the coefficient and negative 2 as the constant term, whose sum is negative 5. So thus their total is 0. So we know that lambda equal to 1 is a root. So that means your first eigenvalue is lambda 1 equal to 1. Now we just want to make sure that this is the eigenvalue which we are looking out for, because they have specified real eigenvalue in the question. So we just want to ensure that lambda 2 and lambda 3 are not real, in the sense that they are complex eigenvalues. So for that we are also going to find out the eigenvalues lambda 2 and lambda 3, just to ensure that whether they are real or complex. Since lambda equal to 1 is the root, we can use synthetic division to find the further roots. So using synthetic division, we get, say this is 1, and then writing all the coefficients, we have 1, negative 3, 4 and negative 2. And we get the first term down 1, then we have got here 1, that's negative 2, that's 2, and then 2 again, which is 0. Thus the quadratic factor from the given equation is going to be lambda square minus 2 lambda plus 2. And if you find the discriminant for this, which is given by b square minus 4ac, so that's going to be negative 2 square minus 4 times a, which is 1, times 2. So that's 4 minus 8, which is a negative number. Thus we know that lambda 2 and lambda 3, these are complex eigenvalues, and of course they will be conjugates of each other. So thus we know that the given vector, the given eigenvector over here, is the eigenvalue corresponding to lambda equals to 1. So now what we are going to do is we are going to solve the equation m times v is equal to lambda times v, and try and find out the values of y and z to get the value of z minus w. So consider the equation mv equals lambda v, which gives us 0, 0, 2, 1, 0, negative 4, 0, 1, 3. V is equal to 2, y and z, which is equal to lambda times v. Now since lambda is 1, this will be eventually equal to v. So that's 2, y and z. So let's multiply on the left. So we will get 0 times 2 plus 0 times y plus 2 times z. Then for the second entry we will get 2 minus 4z, and for the last entry we are going to get y plus 3z. So this is equal to the matrix 2, y and z. Now using the equality of matrices, we get from here that 2z is equal to 2, that means z is equal to 1. From the second row entry we get 2 minus 4z is equal to y, which gives us 2 minus 4 times z is equal to 1. So this will be 2 minus 4 is equal to y, and that gives us that y is equal to negative 2. So thus we have the value of z as 1 and y as minus 2, and we are looking out for z minus y. So z minus y is going to be 1 minus minus 2, that's going to be 3. So the correct answer to this problem is 3. That will fetch you 2 marks. Now let's move on to the next question. So another numerical answer type question, question number 58 for 2 marks. Let M be a 3 by 3 matrix with real entries such that M square is equal to M plus 2I, where I is the 3 by 3 matrix, identity matrix. And if alpha, beta and gamma are the eigenvalues of M such that the product alpha, beta, gamma is equal to -4, then the sum of the eigenvalues alpha plus beta plus gamma is equal to, this is what we wish to calculate. Let us first proceed with the condition that is given to us of m square equals m plus 2i. And rewriting this, we are going to get that m square minus m minus 2i is equal to 0. And we know that the eigenvalues of m are going to satisfy this expression. So in case say lambda is the eigenvalue, then we know that lambda square minus lambda minus 2 is equal to 0, which also gives us that lambda minus 2 lambda plus 1 is equal to 0. Thus from here we get that lambda will be either equal to 2 or lambda will be equal to -1. Now these happen to be the eigenvalues of M. Also note that the matrix M has order 3, so we should have 3 eigenvalues wherein we have only got 2. So lambda 3 is still missing. Thus lambda 3 will have only 2 possibilities. Either it will be equal to 2 or it will be equal to -1. So that's the case of repeated eigenvalues, and we are given this relationship to deal with it. For the sake, say this is alpha equals to, and we have got beta equals -1, and this we are going to call it as lambda. So we need the product of the eigenvalues to be -4. So if I take 2, -1, if we take gamma as 2, then this gives us -4, which is agreeing with the given condition. If we take alpha as 2, beta is -1 and gamma also as -1, then this gives us 2, which is in disagreement. So we can rule out the possibility of the third eigenvalue being -1, and thus we have the 3 eigenvalues to be 2, 2 and -1. And lastly, we got to talk about their sum alpha plus beta plus gamma, and that is going to be equal to 3. So that's another 2 marks. So that's all for today's video. If you find this video helpful, then do like the video and share it with your friends. Also subscribe to my channel if you have not yet subscribed. Thank you so much for watching till here, and happy learning.